Hey guys, this video is going to go over an introduction to inequalities. Alright, so earlier in this unit we were looking at two different equation mats and we were trying to compare to see which one is bigger. So let's just kind of review it real quick. Let's see if we can think of any legal moves. So let's make some zero pairs. Here's a zero pair. Here's a zero pair here. There's a zero pair there. Okay, another legal move is let's take away a couple x's from both sides. A couple x's from both sides. Okay, those are gone. So let's kind of see what I have left. I have an x over here, two ones, three negative ones over here. If you remember, our goal is always to get the x by itself. So I'm going to add in two negative ones over here. Add in two negative ones over here. There's some zero pairs. So on this mat, I have x. On this mat, I have -5. So my question is, which mat is greater? Well, you can't really tell right now because it depends what x is. We've talked about that earlier. Okay, so here's what we're going to be working on now. We want to know what would make mat A greater. What would make this mat bigger? What kind of numbers? Okay, well, I know like 7 would make it bigger. 7 is bigger than -5. Or 5 would make it bigger. Or 10. There's a lot of different answers. So today we're going to learn how to solve an inequality like this. To help us understand inequalities a little bit more, let's kind of read through these situations to help us understand. So first thing, it says your friend is more than 3 minutes late. So let's circle the ones that would show more than 3 minutes. More than 3 minutes would be a bit longer than 3 minutes, right? So 4 minutes, 5 minutes, 6 minutes. Okay, more than is an inequality. All right, the next one, the temperature is at the most 2 degrees. Now, if I say it's at the most, that means that's the highest it can be. So the temperature could be 2 degrees, but then it would be everything lower than that. At the most is another inequality. Okay, the last one, you need at least 4 pieces of paper. If I say you need at least 4 pieces, that means you're going to need 4 pieces or more. You might need 4 or 5 or 6. At least is another key word for an inequality. All right, so definition of an inequality. An inequality is a mathematical sentence that compares expressions. Okay, so we kind of learned these symbols earlier in the year. We have the less than symbol, the greater than symbol, the less than or equal to, and the greater than or equal to. The nice thing about this chart is that there's a couple other key words that are in here. So fewer than, more than. Here's the really important ones. Is at most, shows you what symbol you do. No more than, there's the symbol. At least, no less than. So those are a couple key ones that you'll want to look at and keep those in your notes. All right, so today we're going to try to write inequalities for each word sentence. So in the past we did it with expressions. Now we're going to try to write an inequality. So let's kind of read through this. It says a number C is less than 4. Is less than is kind of a key word. We used to think less than just meant subtract, but if it says it's is less than, that's a key word. If you need to, go look at your chart. Is less than, there's the symbol. So it says C is less than 4. That's my inequality. And that's called an inequality. Let's try the next one. It says a number k plus 5, so I'll write that, k plus 5, is greater than or equal to. So this is telling me that k plus 5 is bigger than or equal to, so I'll put that little symbol, 8. I just wrote an inequality. Let's try another one. It says 4 times the number m, so I'll write 4m, is at the most 16. Now, these are the hard ones to figure out the symbols. At the most, that means it can't be bigger than that. That's the highest it goes. Okay, so that means at the most, and that's up here, here's the symbol. It has to be less than 16 or equal to. Okay, why don't you try these 3 and then push play when you think you have your answers. All right, first one, it says 10 more than x is at least 15. So 10 more than x, I'll do x plus 10, is at least, there's a key word, 15. So you have to figure out what symbol. At least means it's at least 15, could be bigger. So I'm going to do greater than or equal to. The next one, 4 times x, so I'll write 4x, is no less than 15. So no less than means that it's not less than, right? No less than 15. So it has to be bigger than 15, or it could be equal to that. Okay, and then the last one, 3 less than k. So I'll do k minus 3 is no more than 12. If it's not more than 12, it has to be less than 12. Okay, it could be equal to 12 too. So no less, no more than would be, well, it has to be less than. Okay, there we go. All right, the next thing we're going to cover are solutions to inequalities. So solutions are basically same as when we worked with equation, answers that make it true. Okay, so if I asked, look at this first one, could you give me a solution to this? Could you give me a number that made it true? Well, let's just kind of guess. What if x was 6? If I put a 6 in there, is 6 bigger than or equal to 5? Yes, so that's a solution. What if I said x is 3? So if I plugged a 3 in for x, is 3 bigger than or equal to 5? No, it's not. So that is not a solution. Okay, same thing down here. What if I said, is x equals 5? Is that a solution to this one? So 5 plus 2, that's 7. Is 7 less than 4? No, so that's not a solution. Okay, so a solution is an answer that makes it true. So I want to know on these ones, is the number 3 a solution to these inequalities? I'll do the first one with you, and then I want you to try the next two. So basically, you're just going to plug in 3 there and test it out. So it says 3 plus 4, which is 7. Is 7 less than 6? No. So 3 is not a solution to that one. Okay, try the next two. Okay, so let's try this one again. Plug in a 3. 9 minus 3 is bigger than or equal to 6. 9 minus 3 is 6. 6 is bigger than or equal to 6. Well, it's equal to, so yes. 3 is a solution to that one. And then the last one, let's plug in a 3. 18 divided by 3, that's 6. Is 6 less than or equal to 10? Well, yeah, it's less than 10. So 3 is a solution to that one. All right, the next thing I'm going to show you how to do is graph inequalities. Now, there are a lot of steps for graphing inequalities. So right now, I want you to kind of read through these, push pause, read through them, fill in the notes that are missing, and then I'll go through it as we actually graph one together. This is just one other page of notes. You'll understand this more when I go through the example. But I just want to point out, when I say the word open circle, that's a circle that's not filled in. When I say closed circle, that's a circle that is filled in. Please put a J for January by your name in the top corner of your paper. All right, to graph an inequality, here are the steps. So first thing, it says that x has to be bigger than 2. So basically, I just kind of read it. X is greater than 2. I want to show on this number line all the numbers that make this true. So think about all the numbers that make that true. Well, I know 3 is bigger than 2, 4 is bigger than 2, 5, 6, 2.1 is bigger than 2. There's lots of numbers bigger than 2. So to show that on the number line, you're going to come down to the 2. You're going to put a circle above the 2. Okay, now you have to decide, do I need to fill that circle in or not? And to test that, you just plug in a 2. Is 2 bigger than 2? It's not. So 2 is not a solution to this. But every number bigger than 2 works, right? Like 2.1, 2.2, 2.5, those are all bigger. So it's all the numbers bigger than 2. Now if I want to show all the numbers bigger than 2, that's all the numbers over here, right? So you're going to just connect an arrow here and say, I want all these numbers bigger than 2. Those all work in that inequality. 2, 3, 4, keeps going. Now, if you weren't sure which way to draw your arrow, just pick a test point. Like, let's test 4. I'll plug it in. 4, is that bigger than 2? Yep, that helps you know you have to draw your arrow that way. Let's try another one. This time it says x is less than or equal to negative 3. Okay, so first thing, you're going to come to negative 3. You're going to put your circle. Okay? Now, it has this little or equal to. That means it can be equal to negative 3. So you get to fill that in this time. When it's equal to, you fill the circle in. Now, it wants all the numbers that are, this x stands for all the numbers that are less than 3. So the numbers less than or equal to 3 are all the numbers over here. Now, if you weren't sure if your arrow was supposed to go this way or that way, you could just test. Let's just say I tested 0. I wanted to see if my arrow went that way. Plug in a 0. Is 0 less than or equal to negative 3? No, 0 is actually bigger than that. So you know your arrow does not go that way. Okay, it's the numbers less than that, so it's all these numbers over here work in this inequality. So again, we're just trying to show all the numbers that I could put in for x on the number line. I could put in negative 3, negative 4, negative 5, lots of numbers, all the numbers less than negative 3. Okay, how about this one? If I asked you to graph one, okay, first thing that I would do is always look at what number you're using. It's a 5. So I'm just going to go ahead, put 0 on a number line, and then I'm going to put 1, 2, 3, 4, 5. I always like to do a couple more, 6, 7, And then I should do a couple this way. -1, -2, -3. Okay, the 5, that's a number that's actually called the boundary point. You might hear me say that. That's the number where it's kind of your starting point. Okay, you need to decide, is it open or closed? Well, it says 5 is less than or equal to k. If it ever is that equal to, 5 counts. You can use 5. Now, if you read this, again, it says 5 is less than or equal to k. So if 5 is less than or equal to k, you have to decide, do I want all the numbers bigger than 5 or less than 5? Now, especially on one like this, because I know it's kind of confusing, I would actually just pick a test point. So let's try 7. Let's plug it in. 5 is less than or equal to 7. Is that true? Is 5 less than 7? Yes. So we want all of these numbers. So 5, 6, 7, 8, all of those numbers are going to work in there. Because you want all the numbers bigger than 5, right? So there's my solution to that inequality. Okay, let's try one more problem. Now, we have one that's actually graphed this time. I want to see if you can go backwards and figure out what the inequality was. So first thing I would always kind of see, well, where was that boundary point? Well, it looks like it was 1. Okay, now I'm going to take all the numbers. I can see it's going this way. All the numbers less than 1. Well, all the numbers I'm just going to call x. So I'm going to take, there's my x. I want them to be less than 1. So to show x is less than 1, I would just put x is less than 1. So I want all the numbers, that's this, smaller than 1. It can't be equal to 1 because it's not filled in. One more. So again, let's look at our boundary point. It's 1 again, okay? And I have x. These are all the numbers. Looks like less than 1 again, but this time it's less than or equal to 1. All right, so tomorrow we're going to work a little bit more on inequalities and learn more new things to kind of go with the stuff you just learned in this video.